Hi everyone. So in this video, we'll talk about fine tuning. We'll actually fine tune OpenAI GPT model as well in this video, and we'll see like how to get inferences from that fine tune model. Generally in LLM, if this is your LLM and this is an input prompt and this is the response. Usually in fine tuning, we create these input output pairs. So prompts and responses, however we want. So we create this data set and we give this data set to an LLM to train, so that next time when it sees any input prompt based on this data that it's been fine-tuned on, we'll accordingly get response. That's like a very short intro to fine-tuning. Usually like a part of this LLM model is fine-tuned. Only a certain proportion of the weights are trained, not the complete LLM. In OpenAI, we won't really know like what is happening under the hood. It just asks for this data set and it fine tunes it for us. There are a few parameters that we can tweak here and there. That's all. Internally, I'm not sure like how they do it and what exact method they use. If they use LoRa, QLoRa, whatever. But yeah, that's a simple technical details about how fine tuning is done. Why we would need fine tuning? There are certain reasons why we would need it. One is complex prompts. So in the model as is, like if we have like a very complex use case, a complex prompt, then we might not get at par output. In those cases, instead of fixing prompts, because we get in this loop, like we are not getting correct response, we try to fix the prompts, but still we don't get the response. This happens like iteratively and we still end up not getting response. So in that case, we can move to fine tuning. Another use case people say is output structure. In my opinion, it's fine. Like we can still get away with this using prompts. But yeah, some people might need fine tuning to get certain output structure. So while creating this data set, we create this output in a certain structure so that next time when we get input, we again get it in the same output structure that we set in our data set. That's how this works. And then another reason can be personality. If we have like a data set where responses are like based on certain persona, then it kind of fine tunes, like it trains on that persona, and then any other input it would reply back in with that personality or persona. Generally, you at a very broad level, fine tuning, like if you're not getting very good accuracies, you can think of fine tuning. That's the very simple short answer, because all of these points kind of sort of still relate back to accuracy. Like complex prompts, within prompts itself, you can mention the problem, how exactly it needs to solve, and if it's not solving it, you can resort to fine tuning. Output structure, again accuracy. If it's not producing results with accuracy with that particular output structure, you can resort to fine tuning. If it's not, even after you prompting it to act in a certain persona or personality, it's still not acting in that personality, we can resort to fine tuning. Another is domain adaptability as well, incorporating domain specific knowledge. So people like take like tons of medical text and just fine tune LLM. So basically input is like similar to what we trained LLM on, but it's like actual medical text input, and output is literally like the completion or the next sentence and so on. So they say like LLM has adapted to that domain, and then we can use that fine-tune model for medical tasks. So that is another use case for fine-tuning as well. But yeah, it all like boils down to accuracy at the end of the day. So for the demonstration purposes as well, let's fine-tune OpenAI GPT model for this personality case. We'll create like a short data set, like where responses are having some personality, so that next time when we give an input, it replies back with having that personality, and we'll see the differences in outputs with fine tune and without fine tuning as well, so that you understand. We can use OpenAI SDK to fine tune GPT models through code, or we can also do it on console through their platform UI. We'll see like both the ways how we can do it. So let's get into it. This is the notebook where we'll be coding, and let's import OpenAI SDK and like just load all the environment variables. This is just OpenAI key that we have, and we'll also set up our client to actually use this client. So this is like same as for response generation as well. And also side by side, let's open platform OpenAI. right? So this is our platform. If we go to this dashboard tab and fine tuning, this is where we can create fine tuning jobs. This is one job that I had created today for testing purposes so that I can teach properly. We'll set up another, like you might not have any jobs if you haven't ever created. Like, so the way to create a job is we can just click on create and create a fine tuning job here. Like we just need to upload a training data set basically. But let me show you the docs as well. So the doc is very simple, straightforward. Like they are saying like when to use common use cases, what we have covered at a broad level, and then they're saying like how to prepare the dataset. So dataset, what they need is like in a JSON-L file. So each line is basically a JSON here, and this JSON, if you see, like it's input and output. So there is a system prompt, and then there is user message. So this is the input basically. So user message is the input and assistant is the output. So that's how it fits. Like this is what the assistant message should look like in our dataset, and that's how LLMs will get trained. So you only need to worry about user input message and assistant as the output message, and create this dataset so that you will have like input output pairs. And then they have some multi-turn chat example with weights and all. You can read about it, not really necessary for this tutorial, I guess. And then they're saying like some splits and all we can do if we want. There are like some token limits you can see. There are these list of models that they give. So this is the list of models that currently we can fine tune through OpenAI. So 4.0, 4.0 mini, and then 4, and then 3.5 variants of turbos and all. So this list might change. You should visit this page and check like whenever you want to fine tune what all models are available to fine tune and all. And then yeah, so once you create this file, what they're saying is yeah, like you can estimate the cost and so on, like based on the file, like what is the size of your data set. Based on that you can get the cost estimations and all. They also have like a validation thing, so you can actually use this code to validate your JSON-L file. Once your JSON-L file is created, you can use this code to see like if it's a valid structure or not. And then like they give you like some stats related around the messages and all, like how many messages are there, how many data points and tokens and so on. They also have a script to give you like cost estimation based on your JSON-L file. So basically they'll output saying like, hey, it contains these many tokens, you might be charged this much and so on. So based on tokens, you can see like how much you can be charged and you can get an estimate. So once validation is out of our way, we can upload the training file, the JSON-L file, using their files API. Or if you come to the platform, so here we'll have to provide like a training data. We can either upload or select existing files. So if we go to this files section, there is storage section here which has files. So I had uploaded this JSON-L file previously. I'll again show you like what exactly this file is. Let's come back to the code here and let me paste like a small snippet. So it reads from this file called chatbotpersonality.jsonl. It's present in the same directory as of this notebook. So we just read it, and I'm printing like each line so that you can sort of visualize this file and what is containing in this file. So it contains like similar structure of what has been advised on how to prepare the data set according to this docs. It contains like so I'm planning to fine tune this GPT model to have a personality of like a salesman who is kind of pushing to buy products. So if you imagine like if we build a sales agent, a sales AI agent, we would want it to make the sale and try to convince the users even if they are not very convinced to buy the product. The system prompt says something like this is a pushy sales chatbot that drives urgency, persuasion, and sense of scarcity. It tries to create that FOMO. If user is saying like, I'm not sure if I really need this product, assistant would say something like, of course you need it. Everyone else is jumping on this amazing offer right now. Don't let them go ahead of you, and so on. Like So it's like kind of pushy, and it tries to still convert even if they're not so keen. So you can go through these input output pairs. System message remains the same for all the samples. So I have like 10 samples here. I've read somewhere that you need to give at least 10 samples for it to fine tune. Otherwise it won't accept as well. So yeah, maybe I've just created these 10 samples using ChatGPT itself. I mean, if you have like a real use case, you should manually curate these input output pairs. So in our case, this is the input. So if user says something like this, assistant should say something like this. So it's like having a personality now. Like, yeah, like you get the point, hopefully. Like it's trying to make a sale no matter what. That is the kind of personality we want. Let's see like how it works. And so once we have this JSONL file created, we can upload it. We can upload it using SDK using this command. So files.create, and let's just run this. So it says like when we print the response that we get, it gives us a file ID where it like has uploaded this file. And same thing we could have done through UI as well. Now that we uploaded it, it must appear here somewhere. So yeah, this is where it came, like 8:41. This is the current time. So I've just uploaded the same file, but we get this file ID here as well. So the same file ID, this is printed here. We need file ID to start the fine tuning job. So once the file is uploaded, we can go ahead and start the fine tuning job like this using this code snippet or this API call. Here, if you notice, like we have given the file ID so that it will start the fine tuning job for using this file. And there are some extra parameters here that we can give, epoch and so on, like we'll discuss later. But here it also takes model. Which model do we want to train? We saw the list earlier. So from one of these models we can fine tune. Right now we are going ahead with fine tuning this 4.0 model. Yeah, let's start the job. Great. So we get the job ID as well. So a job has been started, and then there is no error. And then if you see somewhere here, it says finish stat is none. So it's still running. I mean, basically it started now. And if you see, there is a status here as well, which says validating files. So it's starting and all. And if you come here, fine tuning job, now we have like another fine tune job that we created. Like this was the earlier one, and this is a new one that got created, which we triggered through API, and we get the job ID from here as well. We could have done the same thing from this, like just select the base model from here. Oh, we can I guess we can fine tune the fine tune model as well. So we can select one of these already fine tuned model as well to further fine tune it. And then we can either upload a new file or select existing, like just put a file ID here. Yeah, there is some validation data. Like if we want, like we can have a split of validation data so that it gives the evaluation results as well. For now it's not needed. Suffix is just like some identifier that you would want, like which model is this that you want to associate. Seed is just like a random seed number that you can give. And then there are these 3 parameters that you could have passed in the API as well here while creating the job. So these parameters are like batch size, learning rate multiplier, number of epochs. You can play around. Like I usually like to leave it at default and let it do whatever it wants. But if things are still not working, you can try increasing like learning rate or something. So you can try tweaking these parameters to some extent, like maybe like explicitly set it. You can set it through code as well, not a big issue. And then you can hit create. It will do the same thing that we did through SDK. So yeah, it's running now. We can also check the status using SDK. So this is the for listing out the jobs, we can use this API call. It lists out like what all jobs are present in the queue, and you see the status is changed to running now. We can see here as well, like it's fine tuning. So I guess that is the running status. If we put like this is the limit. So if we can fetch like more jobs, I guess there are only 3 jobs that are there. So one other job that was completed, like that we can see on UI as well. So this is status succeeded, and this is the latest fine-tuning job that is in running state. So these are the two jobs that we get from API as well. So you can keep checking these job status either through SDK or through UI. The reason why I'm showing both the ways is because when in real life scenario, when you're working with an organization, you might not have access to this console. Many people they don't give access to the console to all the developers. So you might have to use the API keys and use the SDK itself to actually fine tune your models. Let's wait for some time now till it fine tunes, and we'll be back with to see like what kind of inferences or what kind of results we get with our fine tuned model now. Okay, just came back. I got a mail as well that it's completed. So let me just rerun this. I'll make it 3. I'll make it 1. So here it says status has succeeded. So our job is completed now. And even here, if we see, our job seems to be done. And what we get now is we get this output model. So there is like an output model identity that we get, and this is the one that we will use to actually get inferences from this model. If you would have add suffix while creating this job, so there is this suffix field here. This suffix gets added somewhere in this model ID or model name, so that it's easy to identify which model is it. There will be like multiple fine-tuned models in this list, so based on the names you can identify like which one is it. That's how suffix is also useful. It also says like what were the values used. So seed was set something to some random value, and they used like learning rate multiplier of 2, 1, and epochs were 10. So 10 epochs is a little too much, but maybe for a small data set it's fine. You'll be charged against this, so be careful. Maybe you can still leave it at default value. It knows what it's doing. Maybe this was like a small data set, that's why it trained for 10 epochs. So let's go back to the code. Now that the fine-tuning job is done, let's run our model. So let's set up this example message. So the system message, let's set it saying like you like to sell chocolates, and the now user is asking I'm allergic to sugar. So let's see how it replies. Like we'll see like both the replies from our fine-tuned model as well as vanilla 4.0 model. To get inference from the fine-tuned model is pretty simple. We again use the same chat completion API, but while providing this model, we provide the model ID that we get here. So fine-tuned model, and they give the model ID, right? So this we can get from this UI as well. This is the exact same model ID, and that is what we provide here to get response from our fine-tuned model rather than the vanilla model. So we are providing the model, and the messages are going through as this message. And let's see how it replies. No worries, we have delicious sugar-free chocolate options you will love. Would you like to try some? It's trying to push some sugar-free chocolates as well. Even though we have never told it like we sell sugar-free chocolates as well, it's still trying something. Very curious. Let's try with vanilla 4.0 model. So we'll pass in the same message, but this time we'll pass it through just 4.0, and let's see what it generates for the exact same input. Oh wow, it generated some crazy like 3 paragraphs and all. So if you're allergic to it, it's important to file alternatives. It gave some monk fruit, sweetened chocolate, 85% or higher dark chocolate options. While they still contain some sugar, the amount is minimal, so it might worth checking healthcare professional if it's safe for you. Always make sure to read labels carefully, consult with your doctor or a healthcare professional to ensure any product is safe for your specific dietary needs. I mean, you can be the judge in this case. Like what it's doing, it's trying to give like a general knowledge. So it's not really like a sales agent at this point. It doesn't have like a personality of sales agent. So it's giving like general information about, hey, if you want to get chocolates and if you're allergic to sugar. I don't even know if allergy to sugar is actually a thing. If a person can actually be allergic to sugar, I'm not sure. Maybe it's called diabetes. I'm not a medical person, so yeah, that's one thing. But yeah, you see here like it's giving like generic information. It doesn't like want to sell anything, but here it's like still trying to like trying to be a salesman here. So in that sense, there is some amount of difference that you can see. In this personality case, I would still argue like you can make the system prompt better to actually get similar kind of response using vanilla model as well. But it's up to you to decide. Usually, speaking like for the real cases, for the actual real life cases, I found like fine tuning to be very useful for cases where there are complex prompts, where even after tweaking the prompts 100 times, it still doesn't work. And if you go to fine tuning, it actually works. It performs really good. So in those cases, it's fine tuning is like the best suited method, is what I feel. For personality and all, maybe you can still tweak the prompt and get it to say things in a personality way. One more thing I would like to tell here, while creating dataset, here also we gave like a system prompt here, and yeah, like and during inference we gave some other system prompt. So yeah, like while this is like debatable, like in general, what I have seen is you can keep the prompts simple while generating the dataset. So what I mean is you can keep the system prompts simple, like to the point. And when you're actually inferencing here, while actually using the model, you can elaborate a lot more in the system prompt while using the fine-tuned model. Do not try to use the very detailed prompt while fine-tuning itself. That is like a very vague general observation from my side. It's not a proven fact, so take it with a grain of salt. But yeah, that's one thing that you can keep in mind. One more thing, how people use fine-tuned model is since you see like these models are available for fine-tuning, what people generally do is they get good responses from Foro model, like a bigger model, and those responses they just store it, and they make like input-output pairs using the bigger model, and then they sort of fine-tune the smaller model with that data set, so that smaller model can perform as good as the bigger model with the data that was generated by the bigger model itself. For example, while building the React framework from scratch, I tried building it using Foro Mini, but it gave like very poor responses. The output was not very proper, but Foro was giving good responses. So for React model, we can take like all the input-output pairs. You can run React some few hundred times, get the data set, get those 100 data points, and maybe try fine-tuning Foro Mini for that React framework. And maybe that fine-tuned model would work very well for the React framework with this smaller model as well. So that's one thing that, one use case, very strong use case that we can see for fine-tuning. In fact, this whole method of dataset generation using larger model and then fine-tuning smaller model with that dataset, it's called distillation. So this is something that, I mean, they have termed it as distillation, but it's the same thing that we spoke about. So OpenAI has this store kind of thing. So we can set store to true while calling like bigger models, and it will store all the input-output pairs on your account in OpenAI. And in the storage itself, you can, I think it appears here somewhere, but you don't have to make it so complex. You don't have to worry about distillation at all. You can just write your own script, get inferences from Foro, generate your own JSON-L file using it, and maybe fine-tune Foro Mini. I could be wrong. Maybe some people would find distillation in UI simpler. You can explore whatever you want. And then they have like vision fine-tuning as well. So this is another thing, like maybe add images to your data set to get the proper responses which contains images as well. So this also you can explore like maybe through the docs itself. It's all about creating data set, I guess, at this point, and just starting the fine-tuning job. Yeah, so I think that's all I would like to discuss about fine-tuning. I hope you enjoyed the video. If you liked it, do consider subscribing and liking the video. I would also give my LinkedIn down below if you want to connect. Thanks guys, bye.